Welcome to my YouTube channel, and today we're going to look at Laplace transform. And this is a question that I was doing and did the introduction, but I will repeat. And the question says find the Laplace transform of t squared sine 3t. Then secondly, the inverse Laplace transform of f of s equals to s plus 1 everything divided by s cubed plus s power 2 minus 6x, and the two question carries 10 marks, evenly distributed. So for the first part, which is the Laplace transform of t square sine 3t, so we need to recall a formula, that is the Laplace transform of sine 80, which is a s square minus a squared, and again another formula, that the Laplace transform of t to the power of n f of t. Now the f of t is the sine of 80 in this case, is given by negative 1 to the power of n, then multiplied by the derivative of d of n with respect to s, d of s to the power of n of the Laplace transform of f of t. So we know that from this formula, sine 80 related to sine 3t, then from 3, and that's why we have in sine, the Laplace transform of sine 3t is 3 over s squared plus 9, and then applying the second formula, this is the Laplace transform of 2t squared sine 3t, it is negative 1 to the power of 2, then second derivative with respect to s of 3 everything divided by sine of s squared plus 9, and therefore this is equivalent to the first derivative into with respect to d over d of s, or everything multiplied by 3 s squared plus 9, and from this one we can simply say that this is d of s into, so we are applying quotient rule of differentiation, whereby it is u, so this is u over v, so you hold v constant, you differentiate v, then you subtract v, you differentiate u, then everything v squared. So this is the formula we are going to use, and this is what we refer to as the quotient rule for differentiation. Quotient rule for differentiation, and with that you can simply say that we hold the s, this is the, so this is equivalent to s square plus 9 of ds of 3, then we hold 3 constant, d of ds of s square plus 9, then we divide everything by into bracket s square plus 9 everything squared, and upon simplification this gives d of ds being equals to, so this derivative here gives a 0. So that means everything on this side becomes a 0. So we're remaining with minus 3 multiplied by, if you differentiate this, you give 2s divided by s squared plus 9, everything squared. And this is equivalent to d of ds minus 6s into s plus 9, s squared plus 9, everything squared. So again, we differentiate this by quotient rule, and this is to say s squared plus 9, everything squared, d of ds of negative 6s minus then on the numerator you have negative 6, so again into bracket minus 6s d of ds of s squared plus 9, everything squared. So we divide by s squared plus 9, and this time to the power of 4. So this simply becomes minus 6 into s squared plus 9 squared minus minus into 6s, and this is the derivative here, you get 2 into s squared plus 9, then 2 to the less 1 from this power, then you multiply by d of ds of s squared plus 9, then you close your bracket, everything divided by s squared plus 9 to the 4th power. And this simply implies that this is negative 6 into s squared plus 9 squared minus minus 6s, was that bracket, into 2 into s squared plus 9 multiplied by the derivative of this, which is 2s. So you close that bracket, divide by s squared plus 9 to the 4th power. So if we simplify this, you realize that this sign changes to be positive. So this is equivalent to saying that this is minus 6 into s squared plus 9, everything squared, plus 6s into 2. So you have 2 and this 2, so this becomes 4s into s squared plus 9. You divide by s squared plus 9 to the power of 4. So you can simply say that this is equivalent to minus 6s, so minus 6 into s squared plus 9, everything squared, plus, if you multiply this and this gives 24s square into s square plus 9, you divide by s square plus 9 multiplied by s square plus 9, everything cubed. So this one and this one will cancel out, and now we remain with, after simplifying that, we remain with minus 6 s square minus 54 plus 24s squared, everything you divide by s square plus 9 cubed. And this, after you've simplified this, will give 18s square minus 54, everything divided by s square plus 9, everything cubic, everything cubic. And that is the solution to the first part. Now the second part says that this is Roman 2, you get the inverse Laplace transform of f of s equivalent to s plus 1. Then this is, we have 3s cubed plus s minus 6s. So this is inverse Laplace transform of s plus 1 s cubed plus s square minus 6s. And this is, in other words, you can simply put it as inverse Laplace transform of s plus 1 s into s square plus s minus 6. So by partial fractions, we can simply say that the inverse Laplace transform of s plus 1 over s into s plus 3 into s minus 2 and this can be written as inverse Laplace transform a over s plus over s minus 2 plus c over s minus plus 3, sorry. And we can simply say the numerator part here, that is s, is equivalent to a into s square plus s minus 6 plus b into s plus 3 multiplied by s plus c of s into s minus 2. Then again s plus 1 is equivalent to a, now we are simplifying, into s square plus s minus 6 plus b of s, the s here, s plus 3 plus cs of s minus 2. So when s equals to 0, we have 1. When s equals to 0, when this s is equivalent to 0, we are left with 1 being equals to minus 6a. So therefore a is equivalent to minus 1 over 6. A is equivalent to minus 1 over 6. And again, when s equals to 2, when s equals to 2, when s equals to 2, we have 3 being equals to 0 of a plus 10b plus 0 of c, and therefore 3 is equivalent to b, which therefore implies that b is equals to 3 over 10. Then when s equals to negative 3, when s equals to negative 3, we have minus 2 being equals to 0 plus 0 plus 15c, and therefore minus 2 is equivalent to 15c, which therefore implies that c equals to minus 2 over 15. Now from there we have the three values of a, b, and c, and we can simply say now, if we borrow from this part, we can simply say that inverse Laplace transform of negative 1 over 6 divided by s plus 3 over 10 divided by s minus 2 plus 2 over 15 divided by s plus 3 is equivalent to now here we read the values direct from the Laplace table. So this is the first part, can be read as 1 over negative 1 over 6 multiplied by 1 over s, and the Laplace transform of 1 over s is 1, so this remains as negative 1 over 6 plus this is 3 over 10 inverse Laplace transform of s minus 2 is equivalent to exponential 2t, and there's somewhere where we messed something. Oh yes, here. This is supposed to be negative. Sorry, this is negative because of the minus 2 over 5 here. So this is negative. So this is minus 2 over 15 to the Laplace transform of 1 over s plus 3 is equivalent to exponential of negative 3t. And with that doing, we've gotten our Laplace, our inverse Laplace transform of the given function. So thank you, my viewers. Subscribe for more. Subscribe for more of such caliber. Goodbye.